You come with me, sir. This is my master, David Nagel.
Nice to meet you.
Hi, sir.
Good to see you.
I hope you trust me, sir. This is Alex Rappening. He's a researcher at the University of Colorado. He's going to present something on AgentSheets, sir.
Thank you.
Like, spreadsheets,
Alex, all yours.
AgentSheets. Thank you, sir.
Good pleasure.
Hello.
It's the same one we were just on. He's not on his screen. Immediately after Alex, right?
So far we have talked about, can you hear me? About agents that are very powerful and intelligent, and sometimes you might wonder how intelligent can they really be, or should they be? Can we trust them? So the kind of things we were interested in is sort of different in the sense that we were looking at a very different level of agents. Instead of having one really intelligent kind of agent that you don't know quite if you can trust that guy, we have a lot of agents. They're kind of dumb agents, but they communicate with each other. And the kind of things you can do with these kind of agents I will show you in this demo. So that's sort of the framework that you see on the screen here. That you have this application called AgentSheets, which, by the way, is built in MCL, I should mention. Okay. And all the agents, they're in charge of doing little behaviors and communicating with each other. So that's really the essence, that they share a space and do a lot of tasks together. They have sensors which allow them to react to the user, like clicking and so on, or to other agents. And they have methods and effectors that allow them to communicate with other agents that are either in the same kind of worksheet or over Apple events, that to other agents that work there in the AgentSheet environment, like turn on the microphone and do these kind of things. So that's the first. I will show you a sequence of different applications that have been developed on top of the AgentSheet environment by different people. So if I have a trouble using them, then it's due to the fact that other people have developed most of these things. And they haven't really told me all their tricks. They just said it's very simple to do this demo. We will see. So in the upper window, you see sort of an agent repository, in this case of an electric world. So all these little guys here are little agents. And down here, we have these agents. They're in a little worksheet, and they're all here to communicate. So I will turn on electricity, and then I can interact with these. So the communication is very implicit in the sense that there's no explicit link between the individual agents, but sort of electricity flows through adjacent agents. Or over here we have an electric coil, and if I switch that on, then we have an interaction with that switch over here that can turn off and on electricity. If you're not quite happy with the way our agent looks, then I switch to the gallery here and I go to the Visual Program Designer view, and I get all these artifacts here. And for instance, I edit the way the bulb looks. And even the editor itself, every pixel is an agent here. So if I now edit my depiction of a bulb, then you can see that this propagates through the picture. So the idea of agents is all over sort of this environment, in the bitmap editor, in the worksheet, and so on. I guess stop this thing. So in the next application, that's a very simple application too. We have two different kinds of agents, being sort of a very naive model of a physical world. One agent models a movable agent, whereas the other one models a static agent. So if I drop agents in my world, then they fall down. And as you can see, they react pretty quick. And that's crucial, because otherwise users get frustrated pretty quickly. So even though we're just doing academic work, we sort of care about these sort of issues. And even if they're just sitting here, sort of, and you think they're static now, if I break out the walls here, then things start to happen again. So the agents are alive all the time. So let's go to the next thing. Obviously, I cannot show you very deep about each individual applications, but I just want to give you sort of an intuition on what you can do with this kind of idea. So this application was done by the Department of Environmental Design, and it's a very simple simulation of a traffic thing. So pretty soon you see some clustering going on, and we could now introduce different other agents like yield signs, stop signs, and so on. And one difference to the other application also is that you have now layers of agents here. The road itself is also an agent. The cars themselves are agents that move on top of the road and they interact with each other. So I could change topologies, or I can make some stupid thing like this. So you see you have a little crash here, and this guy flashes at the other guy because he's sort of frustrated and so on. So the next application is sort of more like a classical visual programming kind of thing. Some person walked up to me with the knowledge of Petri nets, and I had AgentSheets, and we tried to implement it in an afternoon, and that's the result here. So we have a little Petri net. We have two branches here. One branch simulates a process, the other one is a process, and both like to grab a resource. So if you have this set up here and we try to fire the first process, then it can grab the resource, the second one can't. If you finish the first task, then there's the resource again, and the second one can enter. And now we could make this cyclic. So I've introduced some new transitions here and linked them up. So linking is also a communication mechanism in AgentSheets. And again, I put in some tokens. And now we have the cyclic action going on. Okay, that's enough of this. Let's switch to the next application. So far, most of these applications have been programmed by people in the form of writing little Lisp programs and attaching them to the agents. And here's sort of a bizarre kind of benchmark that we do at the University of Colorado, that everybody that creates some sort of a system that happens to be visual, they're supposed to create a simulation for a Turing machine. And this is the AgentSheet version of this bizarre benchmark. So instead of attaching now a Lisp code to this Turing machine to make it work, I'll have a method that allows me to do the same kind of thing graphically. So I have double-clicked the head. I would like to program the head of the Turing machine, and I have two fields here. That's the current situation we are in, and that will be the situation we will be in the future. So I move the head to the right. I remove the context that is irrelevant. And then bad head, maybe. Let's get another one. Okay, so I'll remove the context because these two guys are irrelevant for Turing machines. Move the head to the right, chip, and it happened. So now that behavior is attached to the head. So that's the way we programmed this, and we could now attach a second rule to extend the tape, say. So you want to extend by moving the head to the right, moving this thing to the right, and insert a 0 tape piece. Yep, it wasn't quick enough. So that's what the head did. So that was this application. So in the next application, we have a remodeled a system called Rocky's Boots, and it's called Rocky's Others Boot. And the difference is that the circuit can explain itself. So I don't know if you're familiar with the whole thing. Is you drag a sensor on top of a sensor pad, and then the students have to build a circuit that can detect the graphical attributes. In this case, this didn't fire. This one did. But usually it turned out to be very frustrating for students that they build a circuit and after a while they couldn't explain anymore what was going on. So the person that did this application with AgentSheet added the functionality that the individual agents can explain themselves. And not only can they explain their general functionality, they can explain themselves in the context they're in. So if I double click this guy.
The cross sensor does not detect a cross. It sends a false signal down the wire. The OR gate receives a false signal. The triangle sensor detects a triangle. It sends a true signal down the wire. The AND gate receives a true signal. The circle sensor detects a circle. It sends a true signal down the wire. The AND gate receives a true signal. Since both inputs were true, the AND gate sends a true output signal down the wire. The OR gate receives a true signal. Since the OR gate received at least one true input signal, it sends a true output signal down the wire. The boot receives a true signal and kicks.
So finally, I'd like to show you a more serious or bigger application that people of US West have been done. And it's about voice dialogue design. And apparently their designs are so secret that the only thing I can show you is this very small dialogue. But really, the dialogue that they're developing are very complex, and that's the kind of thing they use for steering services via touch-tone telephones. And so far, they pretty much had to hardwire these kind of units, and for customer to sort of experiment with that kind of setup was pretty unusual. So with this kind of environment that they did, they can simulate circuits and voice dialogue designs very easily. So we have...
You have one new message. To listen to your message, press 1. To change your personal options, press 2. To disconnect,
so they
press
have set up their own language that allows them to design these kind of environments. So it's sort of like I'm calling in with the telephone, it gives me a menu, and I happen to pick 2.
Personal options. To change administrative options, press 1. To record greetings, press 2. To change your recorded name, press 3. To change notification options, press 4. To exit,
so the designers at US West can sit together with the customers that want to design these kind of dialogues, and then they can debug it with sort of 2 user interfaces. The customer only sees the numeric keyboard and gets the acoustic feedback, and the designer sees this kind of environment.
Enter the phone number where the system is to call you to notify you of new messages. The telephone number you have entered is 555-1234.
And so on.
If this is correct, press 1. To change it, press 2.
And with this, I want to conclude my presentation. Thank you.
I understand that Alex just got to University of Colorado, where he goes to school, yesterday from Europe, and was handed all these demos and said, get out to California and do demonstrations. So thank you very much.
Thank you.
Thank you. That was great.